All right, so the first idea is what we want to look at is we want to look at coterminal angles, and coterminal angles are just the angles that are next to each other. Okay, so coterminal angles are just the angles that are next to each other. So for coterminal angles, one is positive and one is negative. Okay, together they make a full circle. So remember, what did we talk about? What we talked about the other day is we talked about everything's in coordination or in the coordinate plane, and we always start over here. Always. So we always start right here. Okay. Now remember, this is part 2 of section 9.3. Okay. So you're going to see this idea of coterminal angles here, and you're going to see this idea of reference angles, and that's what we're going to talk about right now. It says one is positive and one is negative. Together they make a full circle. So when we make an angle, remember we start here 0, 90, halfway is 180, 270, and this comes back to 360. So as I look at this, the biggest thing that you guys should be kind of aware of is I want to be able to create an angle here. So let's make a 50-degree angle. So we'll call this about 50 degrees, and our 50-degree right angle is right here. Okay, so 50 degrees is coterminal with another angle. And that other angle is going to make the full circle. So if 50 degrees is the positive angle, what we're trying to figure out with coterminal means it's the negative angle, which goes around this way, which goes around this way. So how do you figure out the coterminal angle? The coterminal angle is figured out by just getting whatever you have left out of 360. So I'm going to take 50, because that's my positive angle, and I'm going to take out the full circle, and what do I got left over? The full circle leaves me with 310. So 50 degrees is coterminal with negative 310, because these two angles, this guy and this guy, make a full circle together. One positive angle and one negative angle, with their powers combined, will make a full circle. All right, so what we want to be able to do is we want to figure out which one of those go with it. Okay, so here, so what did I do there? I just took the angle minus 360. Okay, so whatever the angle is, to prove it's coterminal, or not prove it, but just to figure out what it's coterminal with, how did we get that? We took the angle, 50, minus one full rotation, which is 360, and whatever you get the negative coterminal teammate that it goes with. So what does 100 degrees go with? 260, because they together would create a 360 degree angle. One is positive, so this would be the positive coterminal. What is his negative cousin? His negative cousin would be negative 310. If you added them up together, just their absolute values of it, just the positive versions, what do both of these make? They would both make a 360 rotation. Okay? They both make the whole circle. One is how much of the pizza did you take? The other is what's left over. Okay? So when we look at that on section 9.3, and it starts talking about coterminal angles are whatever you got left out of 360. So let's do that. So 65, what is it coterminal with? We'll subtract out the 360. And if I do that, 360, I take it out of 65, its coterminal angle is negative 295 degrees. Is it okay to have a negative angle? Yep, these are coterminal. That means they would make up a full circle. One going in the positive direction, one going in the negative direction. Okay? If your angle is bigger than 360, chop it down to size first. What does that mean? That means take out 360. So I'm going to take out 360. So 540, and if I take out the 360, is 180. Okay? But remember, what did I say? A coterminal angle is, and I guess I could highlight it right here on the page, is one positive and 1 negative. So my coterminal angles for 540, one of them would be positive 180. Take the 180, I need my negative angle. Remember, we need your negative angle, and take out the 360. So if you go 180 minus 360, I'm going to get what? I'm going to get negative 180. These guys are coterminal. That means they make up a full circle. Does 180 degrees and another 180 degrees make up a full circle? Yep, it sure does. But Thrasher, this says 540. I know. It means it ends up on the same spot. It's just bigger than one rotation. Okay? So these guys, up here, these guys are in degrees. These guys are in degrees. So what do you do when it's in radians? You still take out a full rotation. But instead of using if it's 360 degrees, remember that's the same thing as 2 pi in terms of radians. Okay, 4 quarters is $1. 5,280 feet is a mile. Okay, so what we want to look at is we want to look at how do we change this. Now, if it said degrees here, you guys would just subtract out the 360. So if it said degrees, I would minus 360 from that. But it doesn't. This is in radians. So instead of 360, what would we take? We'd use its equivalent. We'd use 2 pi. So from here, I'm going to subtract out 2 pi. Now, as far as the math, I'm going to go minus. I'm going to go 2 pi. I'd do that on this one because remember, they want to find angles that are coterminal, and I would do that on this one. Here's generally where kids get stuck with radians because they have to subtract a fraction and a whole number. And maybe because pi is sitting right there. So remember that little reference I just talked about? That like, hey, 5 bananas minus 2 bananas is still 3 bananas. 13/18 pi minus 2 pi is still equal to what? Is still equal to something in terms of pi. So if it has pi involved, your answer will have pi involved. Okay? When you go to the store and you buy apples, you know what the store still has? Apples. You didn't buy them all. I guarantee you, you didn't buy them all. So if you guys are subtracting in there in terms of radians, pi minus however many versions of pi, the only time it'll disappear is if they're exactly the same amount. Okay? If the store has 20 apples and you buy 20 apples, I guess they're all gone. But if these aren't the same numbers, your answer is always going to have pi in it. Okay? Now, we have a fraction. Remember, radians will be in that. So what do I really need to do? I need to subtract these two things. Now, when you have a fraction involved, what do we need? We need what's called a common denominator. So I need a common denominator for this 2 pi to make it a fraction, put it over 1. So now the math that I do is just what you guys did in 7th and 8th grade when you subtracted fractions. Now, did you like it? Did you remember it? I don't know. But we're subtracting. So as far as like degrees and like angle measurements, we're done. We're just subtracting our two fractions to figure out what's coterminal with this. Okay? So 18 on the bottom here, 1 on the bottom here. What would make them both common denominators? 18. So multiply the bottom by 18, multiply the top by 18. Remember, I want this to be equivalent to how much? I want it to be equivalent to 2. 2 is very easy to change into a fraction because the fraction should be a double version of itself. That's what 2 represents. So instantly when I see this one's 9, the other one will be 9, but it'll have 18 on the top because you're subtracting out a double. 2 is a double. Okay? What is 13 minus 36? Because we've got a common denominator. 18 and 18, when the common denominator, the bottom stays common. So 13 minus 36 is what? Is negative 23. So that's where that comes from. Same, same. Remember, the bottom stays what? It stays the same. Okay, over here, 14 pi over 9 minus, I need to have this in terms of ninths. It's 2 pi. So what's double in terms of ninths? 18 ninths. Is this the same as 2? Is 18 divided by 9 the same as 2? It is. Do they have a common denominator? They do. Can I easily write down almost all of my answer right now? I sure can. I can? Yeah. Common on the bottom stays common. Pi subtracted by pi remains as pi. 14 minus 18 is negative 4. So what's the hardest math? It may look ugly, but kids, the only numbers you're subtracting are those top two numbers. Okay, so there are coterminal angles. What is coterminal? That means these two would make what? That means this and this would make a full circle. That means this and this would make a full circle. Just like these guys make a full circle. Coterminal means the two angles, the positive version and the negative version, should make a full circle. Okay? All right, so those are coterminal angles. That's what it means to be coterminal. Just means, hey, what two portions of the circle do we got? Okay? All right, let's talk about reference angles. So reference angles, another new definition. So reference angles are the angle formed between the terminal side and the x-axis. Okay, so to find reference angles, all you're going to do is figure out how far apart or how far away is it from the x-axis. So what you need to kind of realize is you need to know which quadrant the angle is in. What quadrant is the angle in? Okay, if the angle is in quadrant 1, I don't need you to do anything. If the angle is in quadrant 2, take 180 minus that angle. And you'll see why here in a second when I give you the picture. Okay, but these formulas are going to be kind of handy. Okay, if it's in quadrant 3, what I want you to do is I want you to take the angle, whatever the angle is, and I want you to minus 180. So it's kind of like what you do with quadrant 2, but just flip it around. And if it's quadrant 4, what do I want you to do? I want you to take 360 minus the angle. Why do I want to use these numbers? These are the key numbers. Because these key numbers are on the x-axis. Okay? The reference angle just means how far away is this from the x-axis? How far is that? So those formulas, though they're not hard because you're just subtracting, you just kind of got to remember which one goes with what. So as I look at this, just kind of make sure you understand that, hey, when it's in quadrant 1, don't do anything. So you got to know where the angle falls. Okay? If it's in quadrant 2, take 180 minus that angle. If it's in quadrant 3, take the angle minus 180. And if it's in quadrant 4, take 360 minus the angle. Okay? All right, so now I'm going to go back to my examples here. Okay? What I need you to remember, so on this section is totally talking about reference angles. So what I need you to remember is everything is in comparison to what? Everything is in comparison to this x-axis. How far is the angle away from that x-axis? Okay? So you need to be able to draw the angle. And you need to remember that this is quadrant 1, this is quadrant 2, this is 3, this is 4. You start and you move around in a counterclockwise direction. So if I look at number 14, the first thing you got to do is we should probably draw this. Figure out what 225 is. So remember, you have 0, 90, 180, 270, and 360. So if I were to draw 225, 225 is between 180 and 270, so it's somewhere right here. Now, after a while, kids, I don't even need you to draw it. Don't need you to draw it. But there it is. There's where 225 would be. 225 would be right about in here, and it would take up this portion of the circle. Okay? Now, what is the reference angle? So in order to do this in terms of the reference angle, I'm going to slide this over and zoom out just a tad. Okay? What you want to be able to do is you want to be able to look and decide where we're at. So, you're going to ask yourself a question. You're going to say, self, What quadrant are we in? So 225 is in quadrant 3. If it's in quadrant 3, go to your little formula page. Okay, this is quadrant 3. Quadrant 3. What did Thrasher tell us to do on quadrant 3? Ooh, take the angle minus 180. So in quadrant 3, we're going to take the angle minus 180. So he said take the angle minus 180 and figure out what that equals. Well, do we know what the angle is? We do. How much is the angle? 225. 225 minus 180 equals 45. So that equals 45 degrees. So this is what we call my reference angle. What is a reference angle? A reference angle is something that's smaller than 90 degrees. Because we work with stuff. In our right triangles, what's the largest angle? A 90. So we're trying to knock it down into something that we're used to working with. Because deep within here, we can find a triangle. If we eliminate that top curve, what do you notice in here? There's a triangle in there. Okay? So a reference angle is less than 90 degrees. A reference angle is an angle that might land up in quadrant 1, 2, 3, or 4, but overall your answer should be less than 90. If your answer is bigger than 90, you didn't do it right. Okay? So a reference angle, so that's the other good thing that we should know, is the reference angle is the angle formed between the terminal side and the x-axis, and it should be less than 90 degrees. Okay? I guess it could be less than or equal to 90. I'll say less than or equal to 90. So if I ask you what a reference angle is and you tell me it's 109 degrees, you're wrong. Okay? We're trying to knock it down to being less than 90. Coterminal angles, we're trying to knock it down to be the two angles that add up to 360. So they're just key terms. The math is not hard. It's just key terms. Well, again, what is the hardest math? You guys had to subtract those two fractions. Okay? All right, last thing for today is... Now, we already talked about this in your trig functions, kids. So up here, they go through this whole thing about just a review of stuff you know, like the Pythagorean theorem. You guys know that's a squared plus b squared equals c squared. Like, you already know that, I hope. If not, take it. We already talked about what sine is. Sine is the opposite side over the hypotenuse. We talked about cosine is the adjacent side over the hypotenuse. Tangent is the opposite side over adjacent. So those are the three main ones. They're the ones that kids remember. And in section 9.1 and on your Google form, the other ones are just flipped versions of the originals. So cosecant is a flipped version of sine. So it's the same thing, it's just flipped. Okay? So know that those two things are the same, just flipped. Now I should say reciprocal versions, so if some math person watches this and is not happy with my vocabulary, I'm sorry. I apologize. But in these times, I'm more worried about you understanding what I'm saying. Okay, so we're trying to use terms that we're okay with. Okay, so remember, all that's old. None of that is new. So everything that I just did right here is old. Okay, so let's do number 17. Number 17 says the point P, which is at 5, -2. So go graph the point 5, -2. Like if you were to actually graph that, where would that end up? Okay, where would this end up on a graph? Just go plot that point. Go plot 5, -2. To the right, 1, 2, 3, 4, 5. Down 2. There's my point. There's point P. Great. How hard was that? Gosh, I thought we were going triangles and circles. You are. You are. Okay. It says P, the point P, 5 of -2, is a point on the terminal side of theta in standard form. So what does standard form mean? That means standard form, you start here and you go around and it would end right here. Here's your angle. It says find the exact values of your trig functions. Okay, So what did we just make here if we put it in standard form as we go around in the counterclockwise position? We just made an angle that goes all the way around. This is a pretty fat angle. So there you go. Out of the pizza, it took up that much of the pie. So this whole thing, out of the whole circle, it took up a lot. And then you're like, but Dasher, all I see is a circle and it talks about trig functions. Yep, totally agree. But you know what else I see? Besides me seeing the Pac-Man, is I see a triangle. His triangle is the mouth. If I make a straight line down to this dot, I see a right triangle. And in that right triangle, 1, 2, 3, 4, I know this side is 5. 1, 2, I know this side is 2. So do you know the hypotenuse? You actually do, because if you do a squared plus b squared equals c squared, you could figure out this portion of the hypotenuse. This is where triangles get tied in with circles, because they make that angle that forms with the right triangle. So put a squared plus b squared equals c squared. Now, why is that not a negative 2? It can be, but it's a distance. So no triangles that you guys see, do you ever see a negative side on a triangle? Just so you know. Okay, 5 squared is 25, 2 squared is 4. 25 plus 4 is 29 for c squared. I don't want c squared. I want what c equals, so we're going to take the square root. This is what we did the other day. Oh, so this is your hypotenuse. Great, I have all 3 sides of my right triangle. So technically, I'm ready to roll. I can start making my sine, cosine, and tangent, and cosecant, secant, and cotangent. Kids, there's no more math I got to do. I just got to fill them in the right spots of the fraction. Oh, so you got to label them? Yeah, you just need to know which ones are which, but you already know what the hypotenuse is. The hypotenuse is the square root of 29. If you want to make it a decimal, great, but that's just more work, and I don't want to type stuff in. So if you notice, sine is opposite over hypotenuse. Well, the 29 underneath the square root, we already said was the hypotenuse. Cosine uses the hypotenuse. Okay, there it is. Tangent doesn't. Okay. Now, sine, cosine, and tangent. So I need opposite and adjacent. All right. So if Pac-Man's tongue is right here, what is on the opposite side, the front of his mouth, which this side would be considered the opposite. So his teeth are on the opposite side of his back of his mouth there. So 2 would be the opposite side. So do I have sine? Yep, because 2 is opposite. That means 5 has to be adjacent. So I put that in for cosine. And tangent is opposite over adjacent. Great. Kids, you know the ones on the bottom are super easy because you know what you're going to do with them? They're just flipped versions of the same thing. So they're just flipped versions. Cosecant's a flipped version of sine. Secant is a flipped version of cosine. And cotangent is a flipped version of tangent. Hey, look, awesome. You got it. Wonderful. Grand. Okay. So as you guys utilize those, understand that you're just going to have fractions that tie in with the same thing. Okay. So looking at that, don't make that harder than what it is. Don't make that harder than what it is.